Load testing measures performance of a system undergoing a large volume of requests. Before an application is pushed to production, engineers will often load test their software to ensure it is resilient in the face of high traffic. As web applications have changed, the requirements around load testing have changed as well. External APIs, internal undocumented APIs, and proprietary databases are black boxes that you may not be able to test reliably with unit tests or integration tests. Having an end-to-end load testing system can provide a measure of insurance against unknown unknowns before users start engaging with a production version of the application. Mark Gilbert works on performance engineering at Apica, and he joins the show to discuss how load testing software is built and when engineers should use it. Full disclosure, Apica is a sponsor of Software Engineering Daily. Indeed Prime flips the typical model of job search and makes it easy to apply to multiple jobs and get multiple offers. Indeed Prime simplifies your job search and helps you land that ideal software engineering position from companies like Facebook or Uber or Dropbox. Candidates get immediate exposure to top companies with just one simple application to Indeed Prime. And the companies on Prime's exclusive platform message the candidates with salary and equity up front. Indeed Prime is 100% free for candidates. There are no strings attached. Sign up now and help support Software Engineering Daily by going to Indeed.com/SEDaily. That's Indeed.com/SEDaily if you're looking for a job and want a simpler job search experience. You can also put money in your pocket by referring your friends and colleagues. Refer a software engineer to the platform and get $200 when they get contacted by a company, and $2,000 when they accept a job through Prime. You can learn more about this at Indeed.com/prime/referral. That's Indeed.com/prime/referral for the Indeed referral program. Thanks to Indeed for being a continued sponsor of Software Engineering Daily. If I ever leave the podcasting world and need to find a job once again, Indeed Prime will be my first stop. Mark Gilbert is a performance engineer with Apica. Mark, welcome to Software Engineering Daily.
Thank you, Jeffrey.
Today we're going to be talking about load testing. What is load testing?
Load testing is putting an application through load and stress to test its performance and its readiness for the market.
And load testing is meant to test different aspects of system performance. System performance can be a somewhat subjective term. What are the qualities of a system that contribute to its overall performance?
So there are various aspects. There's the application layer, the database layer, the networking layer, and then how all those components kind of fit together. When we look at the performance of those under load, we're looking at CPU utilization, time to the database if available, and then overall response times from the client side.
And how do we test those different types of performance? Because if we're trying to test these different layers, these different areas of performance, I imagine there are different types of load tests we would want to run for those different aspects.
Right. There are quite, a variety of different load tests you could provide. What, we mainly focus on is the HTTP aspect. So what the client or the end user experiences. So we come in with a synthetic transaction that takes the user from A to B, and that in turn has trigger points and trigger mechanisms that then reach internally within the application behind the application layer. But then everything's also reliant on the network. So we're constantly analyzing the network. And then, those trigger points would trigger those back-end systems. Calls would come from the database backwards and forwards. Data would be processed and then returned to the end user.
So this is basically a top-down approach is for the HTTP, because almost every client request is going to be through just HTTP request, and so you want to simulate the high load of lots of users, or maybe a lower number of users with a high volume of requests. So what are some of the reasons why? So when we're load testing, we're doing this to simulate high load events that might occur on a system. What are some of the reasons why load can spike on a system for legitimate reasons when you're not actually just doing a test?
Well, in the common age of 2017, I think one of the biggest impacts or causes of a spike is obviously social media. But then you start looking at other forms of advertising. When something goes out and you become popular and people start coming into your site, those would cause high load events. Additionally, in the e-commerce environment, we have very clearly defined periods during the year where you expect spike. For example, Valentine's Day, which is just around the corner, Mother's Day, and then obviously Black Friday, and then probably Christmas after that, or the holidays.
Yeah, I remember I worked at Amazon for a while, and prior to Black Friday, we would do some pretty big load testing.
Yeah, it gets pretty nutty at the Black Friday period. We get a lot of tests that come up at that time, both on readiness and then capacity planning, that sort of thing.
So when somebody's testing for readiness versus capacity planning, are those different types of tests, or you're just saying these are different incentives that different reasons people have for running a load test?
They would be different incentives, but they can also customize how the load tests are operated. So, what are the key indicators or the success points which need to be clearly defined before the load test, and that's really what we focus in on. If a customer says, can we do X thousand users, we'll test up to that and beyond to find, the breaking point, but also to say, yes, your site can do your expected load, etc.
Could you give us more color on different load testing strategies? Because if you have an online game, for example, your load test might be different than if you're running an e-commerce website or if you're running a travel app. How would a load test differ in these different contexts?
So the easiest way that a load test differs in those is the journey that the user takes. So we record a user journey doing exactly the same steps as a real user does. We are real users. We record it as a real user in a browser. So if it's playing a game, we go through the motions of clicking around, adding, buying gems, or, working through the game mechanics, which then records all those requests. But then when we go to e-commerce, we're more of a traditional shopper. You hit the home page, go to a product listing page, product detail page, perhaps you add to cart, and then go through checkout, or you might log in that process as well. So we capture the entire journey, and then we can turn certain things on and off within that journey. So, if it's a certain percentage that goes through adding to cart, and then a certain percentage that converts into actually finalizing a purchase, we can then add some business logic to that to turn those things on and off. But that's the ultimate difference between any application or platform that we're testing against, is what does the script do?
So that's interesting. So you're talking about the different scripts that people have, and if I'm testing Candy Crush or some similar game, then I would write a script to programmatically have it crush some candy and then spin up 1,000 or 10,000 fake users to run a test of that script. Is that what you're saying, basically?
That is correct.
And to what degree so if you're the candy crushing company, are you monitoring the latency of a What I guess it's totally up to what the company wants to monitor in order for what they're getting out of the load test.
Yeah, primarily what we would want to see is, system performance, so perf-mon stats, what's the CPU doing, how's the memory behaving, I/O, etc. on the hardware layer. But then, on the application layer, if it's available, how many requests are being made to the database? Are those reads and writes? What's the parallelization, if available? And then, response time and network latency, that sort of thing. We cover that automatically through, running the load test. So those are readily available. But everything behind the application is sort of down to the client to define, how they're going to monitor that. In other cases, some customers don't have, extensive monitoring in place. So we do have some agents that can be deployed, which will return those basic perf-mon stats to us, along with the mechanism to send custom metrics in as well. The more data that's available during a load test, though, the better. So the more measurement endpoints we have, the longer it runs, the more accurate the result is going to be.
Simplify continuous delivery with GoCD, the on-premise, open-source, continuous delivery tool by ThoughtWorks. With GoCD, you can easily model complex deployment workflows using pipelines, and you can visualize them end-to-end with its value stream map. You get complete visibility into and control of your company's deployments. At gocd.io/sedaily, you can find out how to bring continuous delivery to your teams. Say goodbye to deployment panic and hello to consistent, predictable deliveries. Visit gocd.io/sedaily to learn more about GoCD. Commercial support and enterprise add-ons, including disaster recovery, are available. Thank you to GoCD and thank you to ThoughtWorks. I'm a huge fan of ThoughtWorks and their products, including GoCD. And we're fans of continuous delivery. So check out gocd.io/sedaily. When load spikes in my application, why can't I just dynamically add machines? Why do I need to test for this scenario? Don't I have auto-scaling groups and elastic load balancers that handle all of these high load situations? Why do I need to test for this in 2017?
It's, I think it's down to readiness. While you can have all these great tools, if you don't test them when it does actually come to crunch time, there's certain factors involved in auto-scaling that do need to be considered. What do the images need to look like? Do they need to be put into a ready state? So do they need to install more packages and do any updates? Do they need to make connections to the database? And then with databases, there's only a finite connection number that you can make to the database. And if the database isn't scalable in itself, you'll very soon run out of connections to that, and then everything will start failing. And then finally, when it comes to spinning up those images, what is the spin up time related to that? If it's a few seconds, fantastic. Your system should run really, really well. But if it's several minutes, then that needs to be accommodated through additional user queues or some other mitigations to handle that delay.
Yeah, that answers my question. So we've been talking about load testing in the abstract. I kind of want to understand load testing in practice. If I am an application developer and I'm developing an application, I'm ready to deploy it, where in my workflow do I test the application? Do I load test the application? I mean, I know there's plenty of debates around when you should have automated unit tests or integration tests. Load testing, I feel, is less discussed. Is there a place in the application development workflow where load testing tends to fit?
In experience, the most common place where it does appear is once the application has been built, it's now ready to be deployed. They deploy it and they want to make sure that it's ready. Ideally, though, load testing would happen whenever you do your unit testing and integration testing, and it would become part of your continuous integration workflow. That would be ideal world scenario. But, when budgets are overlooked and, load testing is somewhat overlooked at times, ideally, at the bare minimum, you would always want to load test before any major launch or before and after any major system change. You're adding new layers to the system. You've changed the underlying programming language or, a database or something like that. You've added new nodes. Those would be best to test, once those changes have happened, and then also before, so that you can then compare the results and make sure that you did, in fact, get that performance increase you were hoping on.
The continuous deployment angle sounds compelling. What's the advantage of doing load testing over canarying? Or I guess you could do load testing before canarying. So canarying is where you might release, if you have a new version of your application, you release it to 1% of your population or 5% of your population. You let it bake for a while and make sure that nobody's having errors, which is somewhat similar to a load test in a sense, right? So what's the difference between canarying and load testing?
Well, canarying relies on your end users coming in, in their patterns that they do. Load testing, provides that stopgap when you don't know when to count on your end users. But secondly, would you want to subject your end users to something that's potentially performance degrading, where at that point, if a page is taking too long because it's a new version, you tend to have a bounce rate at that point. Users will drop off and go somewhere else. So load testing helps you, to test and make sure that it's going to perform really, really well. And then once you've tested it and you know that there is no severe degradation in the user's experience, then introduce your canary testing, because then you can see the effectiveness of those design changes or that workflow change, which then comes down to sort of user preference, and then analyzing their behavior from that. Does that make sense?
It makes complete sense, and especially everybody is setting up continuous deployment these days. If it's as easy as just creating a stage in your continuous deployment pipeline, you might as well have load testing, I guess.
Absolutely. And it doesn't need to be, hugely stressful, just as long as you're adhering to, the same methodology throughout. So if you start with, 50 virtual users, keep on running that each time you deploy code, and any deviation from the previous test, whether it's a degradation or an improvement in performance, should help guide you and reassure you that you're on the right track, or, give you a cue that you need to go and reevaluate something because you might have a hashing function that's gone into an endless loop or something like that.
Yeah, for sure. So, you've got all these layers of applications today: network layer, virtualization layer, containers. And if I'm an application developer, I don't know how to finagle all these layers, perhaps. Or basically, the root of my question is, what kind of observability do you need throughout these layers in order to get the most mileage out of your load test? When you actually run the load test, what are the observability places that you need in order to make this of value?
Right. So that could be like system stats, but then also looking at the stats from the load test, which tell us time spent, and then on a per step basis.
You mentioned something earlier about an agent that so, if you're using an Apica load test, then you have an agent that you deploy to. Is it you deploy it to the host that you're testing?
Yeah.
Is that right?
Yeah, so it's
what does that do?
So we have Linux and Windows agents. They simple perfmon stat agents that run periodically during the load test. And what they do is they send back those perfmon stats to our system. We collate those, and then we present them in near real time, along with when you're historically reviewing, a set of results. So a previous load test that had ran, you can then pull those perfmon stats onto your graphs to see, what the system was doing at that time. In an ideal world, you would have those perfmon stats readily available, but you would also have other counters and other sort of metric collectors which look at, what pages a user is on, what journey he's taken through, and then sort of, your own view of carts per minute, that sort of thing. We also get those based on the page breaks that we have in our script. We do break it down into the actions performed. So it's very easy to then review the results and say, okay, users are coming through on the third step. We see some slowdown. The throughput isn't as great as we were getting on other pages. And that could be a result of, high performance, high database access and load, or, problems with the code, or potentially even configuration issues with the stack itself.
When load testing exposes a problem in an application, what's the typical debugging process for fixing that problem? Are there any typical problems that are exposed during a load test?
Yeah. So some problems that can certainly arise: geographic location, network layer. So perhaps there's a load balancer or elastic load balancer that's in place in front of the application stack. There may be some configuration issues with that. And then when you start looking at the application itself, even certain versions of web servers may have, performance issues. They might have been deployed with a memory leak. So it's helpful to know at the onset of a load test what all those system layers look like and what versions are running, and what flavor of servers are running. And then while the load test runs, other problems that can come up, perhaps it's, a large query that's going to a database, perhaps it's not being cached correctly. So load helps to exaggerate those bottlenecks. And once we've exaggerated them, we can then, really analyze that area of the script to then really find, sort of get an educated answer as to whether it is the network layer or the application layer, or if it's, if it's not visible to us, potentially there's some other layer in the background. So we work the client through, what that process is actually doing to then hone in on what those problems may be.
You mentioned geographic differences. So if I load test an application with a bunch of requests coming from North America,
right?
Is that the same, or what is different if I have a load test with requests coming from another place like Australia or China? Why are these things different?
It all comes down to the networking routes and latency. So, an electronic signal can only travel so fast down the wires. If there's a lot of hops involved in that, perhaps it's really, really far away. It's having to come through a series of networks. All of that will delay that call and increase the user wait time and time to even just make the request. So it's important to, if you're hosting, in North America and your major target audience is North America, test from North America. But if you are a global entity and you have multiple concerns in different countries, you want to get as close to those users as possible to see what the overall impact would be. It also then relates into, kind of like a DDoS environment where you're doing super slow requests to an application. Though once those requests have been made and the connections have been opened, if the traffic is really, really slow going backwards and forwards, that can have a detrimental impact on your application, which is similar to a DDoS. So, a slow loris attack really, takes advantage of those sort of, handicaps that a system could have. So, you've got to test from those locations. And then if you find that there is an issue from one location, that helps you to hone in on who that network provider might be. Perhaps you need to move your data center, or your services, etc.
I want to talk about the requirements for building load testing software because this is what you work on. What are those requirements for building load testing software?
I think essentially is, repeating the end user's behavior as identical as possible. Tests need to be as scientific as you can get them. You need to count on your results from morning to night, week in, week out. Additionally, monitoring is essential. How long does it take to establish a network connection? And with that establishment comes the three-way handshake. So, you've got to monitor everything as well. Look at the specific millisecond timings on when a request was made, when it was received, and then calculate the overall time on that. Additionally, validation. So, are you getting the right status codes that you expect from your application? Are you getting the right MIME types? And are you getting the right content coming back? So you need to test for all those things as well. You need to validate the content that's coming back along with the responses. Any deviation from that could highlight an issue within the application, or it's in a high stress environment. Applications start to act very, very weird when they get super hot, and the requests sort of blend into each other. Systems just start failing, and then instead of getting a 200 response code with a nice error code printed out on the screen, you're getting a 501 standard error, and there's no explanation as to where the problem came from. So validation is super important. And then finally, data handling. So we live in the age of big data. Systems are designed differently based on what data comes in, or they're designed to handle caches differently. Perhaps it's a sharded database. So a variety of data to use in the load test, which then dynamicizes the load test script, is also, of great benefit.
Something interesting you said was the necessity of understanding that your test works properly properly mimics user behavior. It sounds like sort of the Heisenberg uncertainty principle, where by observing something, you are you have a less reliable insight into how it actually works. Maybe you can tell me if that's accurate. I'm just wondering, what are the what kinds of adjustments do you have to make, or how do you have to write code? How does your code end up being different because you have to be so sensitive to accurately mimicking user behavior?
Well, to get 100% replication of what your users can do or do, I think that's quite a tall order. So you need to generalize what users would generally do, as well as perhaps the makeup of your application is designed to take them through a workflow as well. So the chances of them getting 53 layers into the application, to some call that's really obscure, there's had to be a process to get to that. So those are the types of user journeys. While it's while it's not 100% accurate or a complete representation of what users do, you want to try and get it as close to that as possible. So, think times can help us vary that as well. Some users are power users. Some users have used your application a huge amount of times, and they could navigate through the application blindfolded. So they just blaze through, and they hardly wait for a page to load, and they've already clicked the next link. But other users, may, take their time, and they want to absorb and digest what they're looking at. Perhaps they're not so familiar with the application. It's quite complex, and they need to read each step or each, link that's provided. So while we have, a generalized workflow for those users, we can then vary up how they do it and how fast they do it, which can also have a tremendous impact on your application. A 3-second think time as opposed to a 0-second think time can cause way more than just a 3x fold, increase on load. So, quite a few things to consider.
Do you use cloud providers, or are your tests or your test scripts running on servers that you own?
We have a combination of both. We have both our own metal in co-located data centers, as well as utilization of cloud providers.
And how do you use those different resources?
First, it comes down to scale. If we really need to go up into X million concurrent users, obviously when you start looking at companies' infrastructures, that can be quite a constraining factor, as well as budget, etc. So it'd be very, very expensive to have our own metal in a lot of data centers to give us extreme amounts of load. So when load goes up and above our capacities, we would leverage cloud providers. Additionally, some customers may specifically require those locations. So they may have something on the East Coast, but they want to specifically test it from the West Coast, because that's one of the routes they use for internal network. Then, perhaps that's when we would leverage a specific cloud provider. But for the most part, general sort of load tests, several thousand users here and there, those we tend to leverage our own metal for. But, metal and cloud are all becoming the same sort of thing these days. Cloud providers are also providing much more reliable hardware or virtual instances. And so it's becoming, more cost-effective, I think, in the grand scheme of things to utilize cloud when needed.
Your application sits on layers of dynamic infrastructure and supporting services. Datadog brings you visibility into every part of your infrastructure, plus APM for monitoring your application's performance. Dashboarding, collaboration tools, and alerts let you develop your own workflow for observability and incident response. Datadog integrates seamlessly with all of your apps and systems, from Slack to Amazon Web Services, so you can get visibility in minutes. Go to softwareengineeringdaily.com/Datadog to get started with Datadog and get a free t-shirt. With full observability, distributed tracing, and customizable visualizations, Datadog is loved and trusted by thousands of enterprises, including Salesforce, PagerDuty, and Zendesk. If you haven't tried Datadog at your company or on your side project, go to softwareengineeringdaily.com/Datadog to support Software Engineering Daily and get a free t-shirt. Our deepest thanks to Datadog for being a new sponsor of Software Engineering Daily. It is only with the help of sponsors like you that this show is successful. So thanks again. We had a pretty interesting show a while ago about the risks of going deep into a cloud. infrastructure potentials of cloud lock-in, and the guest was advocating host basically, co-located data center stuff, and you can even hire people to manage your co-located data center. And he was arguing that it's not that hard. To some degree, he was a little biased because he's a guy who has started a networking company in the past, so he understands these things a little better than I think the average AWS user. But yeah, give me some more color on your position about cloud versus on-premise these days.
Well, I think, the big gorilla that's in the room with cloud is bad neighbor syndrome. If you're on a virtual, you're on a specific server that contains multiple VMs, and you're one of those VMs, there is potential for other VMs or other customers to overutilize their VM, which then can have a detrimental impact on your application. So that is something that is still kind of out there. It's still something that's being addressed by the market. I think things are improving as time goes on, but there's still a way to go. But I think that's the biggest risk factor. And then obviously, you start looking at depreciation, cost value, etc. I think ultimately, if you had a big blank checkbook and or the ability and the access to getting easy on-prem hosting, then that's ultimately the best way forward. But there are various factors involved there. A being finance or the cost of that. B, how do you manage that? They're now your own dedicated servers. How do you get servers restarted? Perhaps you have a technician that's on site that goes and pushes buttons for you when needed. But there's a lot of logistics involved, in both. I just think, for convenience sake, cloud, and also convenience and cost, to a certain degree, cloud certainly fills in some of those gaps.
To get back to the question of how you build load testing software, what language do you write the tests in?
Us specifically, we use Java. So we have a Java-based tool with its own GUI, and we record with that. And then we can generate additional Java from that, which then becomes the instruction code for the load test itself.
I know there are a ton of APM solutions out there. There's this application performance monitoring market that, as I've been doing the show, reporting on, I go to conferences sometimes, I see, 30 APM companies in a given room. How important is it to build integrations for these different monitoring products? Because I imagine if you are the load testing tool that a company is using, they need to be able to monitor with whatever tool set they have. So what's the integration story?
So integrations can take a while to implement. They can be challenging, but I think the choice of which APMs to support comes down to what we've found, with our customers and what seems to be the most popular. But the importance of, I think it's, at a top level question basis, I think it's really important to incorporate integrations if you can. The more data, as I'd mentioned earlier, the more data points and measurements that you have during a load test, the better educated answers you can come up with, and you're armed with real facts and real world facts of the result of what happened during your load test. And the more facts that you have available, the more the more you can answer your questions with confidence. Yes, we absolutely know that it is a database issue because of X, Y, and Z. In our APM solution, we can see these calls going from this application to the database. But, the read stream is slower, so the, parallelization is off or something like that. Or perhaps there's a specific query that runs in the background in an automated process, which is getting the management information team, some nice metrics and graphs and stuff. But because of the reach that script has into the database and the extreme data that it does consume to aggregate and present results, may have a cyclical detrimental impact on the application as well. So, the more information you have, the better.
How do you test the load testing software itself?
That's a good question. It comes down to a lot of QA. So, we've got very smart developers that work on the application. They do their own testing. But then we also have a QA team. But load testing software, that's... I'm pretty sure they have scripts.
I may have misspoken. I meant to just ask about testing the load testing software.
Right.
I guess load testing. Well, that's interesting. I hadn't even thought about that question, but I guess this gets back to when you need to scale.
Yes.
You probably want to make sure you can scale into AWS comfortably because I guess it's funny because you have Black Friday and then you have the pre-Black Friday load testing, which is probably a load test on your software.
Right. Yeah. So, we do go through the process. There's a lot of peer review as well. We've got quite a large professional services department in both our major locations, and that peer review is these are the engineers that are on the front line with the customers. They are the consultants running the tests. So any misbehavior from the load testing software is very quickly identified and then addressed. But there is also a very extensive sort of vetting process in alpha and beta environments, and the latest code is put there and put through its tests. We have a lot of reliance on the software as well, apart from just load testing. So we also use it in our monitoring platform, and so there's a lot of ways that it can be used. And if it's not performing correctly, those systems would fail very, very quickly. So I think it's a good testing strategy that we have. I'm just not sure on the specific nitty-gritties from the development team.
Fair enough. Can you tell me something about building load testing software that you were surprised to discover since starting to work on it?
How do you mean by load testing software in this case?
Okay, so I find that whatever application I'm building, there's always something that comes out of the project that surprises me. So I'm just always curious about when somebody specializes in a specific software domain. I'm always curious, what is the thing that you can learn about building software from building load testing software that you probably wouldn't learn in any other context?
That is an interesting question. I think,
Disagree with the premise?
No, I totally agree with it. I think the biggest realization that I've had, especially, using load testing software and being an application developer in the past, is the concept of throughput, and its relation to hydraulics. That's at a very sort of mechanical, sort of physical level. But if you're running an application and you don't have the throughput, a load test will help you find that, right? But the load test itself needs to have the throughput in order to generate the load, so it needs to be scalable. So you get to see throughput at its most extreme sort of scale. Think about a meter diameter pipe going into quarter-inch pipe. They don't quite fit. Something's going to blow up somewhere. So that's been my biggest realization, personally speaking, is the importance of throughput. And if throughput isn't, if users aren't flying through the system and responses aren't coming back in a timely fashion, there's definitely a bottleneck somewhere. You fix that, you're not forcing a square peg into a round hole anymore.
An interesting answer.
Was it what you were
You mentioned
expecting, or?
no, and that's what I value
Awesome.
out of it. No,
Awesome.
it's an interesting question. But you mentioned earlier we were discussing DDoS briefly. Does load testing, is that something that you can use to test to see if you're resilient enough to a DDoS, or is a DDoS like a different level of load that you could potentially expect to have under a bad situation?
Specifically talking about the speciality of DDoS, DDoSing in itself has many nuances and ways of generating load and sort of attacking specific weaknesses. A load test can be compared to a DDoS, and it can be used in DDoS readiness testing, but to a certain extent, right? Because there's two main levels of DDoS would be one, the super slow requests, but in extreme amounts of connections being made. But then in the other extreme, a real massive load test coming in when your servers aren't expecting it, and you want to test what mitigation might be in place to prevent that from happening. So I think from an out of the box, yes, load testing could certainly be used as DDoS. But I do say it with caution, because there are many sort of DDoS specialists out there that then start they've got a very scientific method of penetrating and taking advantage of certain weaknesses. So I don't think that if you were specifically doing DDoS that you would only settle on a load test. You would probably want DDoS experts to do that for you. But we can, a load test could certainly help in determining some of those things, especially on the very simple premise of big load and big stress and huge load or huge numbers of users, but super, super slow connections.
Yeah, and you're not going to be able to simulate a Mirai botnet DDoS attack from load testing, but I don't think there's any system that can survive a Mirai botnet attack these days. So that's just kind of,
and that's if you were going to do that with a load test, you would need hundreds of different little scripts and stuff that that look at various nuances of how an application can do stuff. So is the effort worth it at that point?
Yeah. So there are a lot of applications these days that are basically some externally facing API. Like it's an API for third-party services. I think about things like Stripe or Twilio. There's maybe the Yelp API, and I'm wondering how you load test these sort of things, because it seems like with these APIs there's a wide range of request types, so it might be hard to have a comprehensive understanding of what high load looks like. So how do you advise people to devise their load tests when they have an API with a very broad surface area?
I would focus at that point, if it was very broad, lots of methods that do different things. While yes, you could do an A to Z test against all of it, kind of like a smoke test. What value are you getting from that? If a lot of those methods are simply reading from the database and potentially the same table in the database. So at that point, you would want to touch the major aspects of, the most important functions of what that API does. So things like authentication, reading from the database, writing to the database, updating the database, and perhaps creating new records. They all have a different impact on the database, but those are the most important aspects. And then any sort of reliance on other systems like Lambda functions, if they're applicable, those would certainly be something to test. But, with a lot of applications these days, or APIs, I think a lot of developers have taken it a step further by exposing those APIs via, Android or iOS through another application that they've developed, which utilizes that API. It would be looking at the end user scenarios for those, or the journeys that the users would take when using those applications as well.
All right. Well, Mark, I want to thank you so much for coming on to Software Engineering Daily, and thank your company, Apica, for being a sponsor of Software Engineering Daily. It's been a real pleasure getting to know the company, and having you as a sponsor is very helpful.
You're most welcome. It's been great.
Thanks to Symfano for sponsoring Software Engineering Daily. Symfano is a custom engineering shop where senior engineers tackle big tech challenges while learning from each other. Check it out at symfano.com/sedaily. That's symphono.com/sedaily. Thanks again, Symfano.
Wow!